So in this series of videos, what I'm going to do is focus on the Chapter 3 practice test from the text, and I'm going to change the numbers a little bit, vary things up a little bit, but it's going to follow the pattern of the exam, the practice exam, and that'll give you a good setup for figuring out how to do those problems, and that'll get you well prepared for our next exam, because that'll follow the style of the exam. The main chunk of the exam is focused on Chapter 3 material, but you should also know Chapter 2 and Chapter 1 material, because each exam is cumulative. Okay, so the first two questions are, say, given this information, is each one a function? So when we look at number one, well, one thing that we note is that this is the equation of a circle, and a circle fails the vertical line test. If you drew a vertical line through the circle, you would hit 2 points, and so it doesn't work. If it's a function, when you give it an input, it gives you one output, and you know exactly where to put the output. And what you can see is, because of this squaring here, that you're going to, on the y term, you know that negatives and positives are going to result in the same situation. So that's why we can see that we're going to actually hit two outputs. One input can give us two versions of an output. Okay, so this is not a function. Then when we look at this set of ordered pairs, we want to say, is this allowable as a function? So we have an input, and it goes to the output 1. So 2 goes to 1, 1 goes to 2. We're okay so far. 3 goes to 1. So we have, notice that we have 2 goes to 1 and 3 goes to 1. That's okay. We can have two different inputs go to the same output. That's not a problem for a function. But notice here we have another input that gives us a different output. So these two same inputs go to different outputs. So if we plotted them, they'd be in a vertical line with each other. But also, we want each input to give us a unique output, and we don't have that here. So that is also not a function. All right, for numbers 3 and 4, we're going to take this function f of x, and we're going to evaluate it at a certain place. So in this case, we have f of -1. So first, what I like to do is I rewrite my function putting in empty spaces where the variable was. And then now I'm going to replace the x's with my whatever I'm evaluating at, in this case -1. Okay. And then from there I can simplify. I've got -1 squared, which means -1 times -1, so that's a +1. +1 times -5 gives me -5. And here I have a -1 times 3, so I get a -3. So altogether I'm at -8. All right, in the same way, I can rewrite this. And now I'm going to replace my x's with the thing I'm evaluating, in this case 4 plus a, and 4 plus a. Now notice my 4 plus a is squared, so that means 4 plus a times 4 plus a. Sometimes, to keep myself on track, I like to make sure I make a little square here, and note that I'm creating an area that can be broken into 4 smaller areas. So 4 times 4 is 16, 4 times a is 4a, and then we have that again, and then we have a times a, which is a squared. Okay. Now, each of these is within my parentheses. Each of these is going to be multiplied by -5. So I have my a squared. I'm going to multiply that by -5, -5a squared. Then these two are like terms. I'm going to call that 8a, and I'm going to multiply by -5. So I have -40a. And then I have my 16, which I'm going to multiply by -5. So 16 times 5, 10 times 5 would be 50, and then 6 times 5 is 30, so I get -80. So that takes care of the first piece, and then I'm adding my section over here, so that's 12 plus 3a, and now I'm going to simplify, so I have negative 5a squared, I have negative 40a and positive 3a, so that's negative 37a, and then I have negative 80 and positive 12. If I had positive 10, that'd be negative 70, and then I have two more, so negative 68. All right. And then that takes care of these pieces. So f of 4 plus a ends up being this trinomial here.